So my paper is about an AI-powered framework to assist humans with converting metadata to semantic web format for photo archives. And I'm going to talk first a little bit about the reasoning behind the project, then go through the elements involved in the framework.
Sorry to interrupt. There's a little bit of an echo. I don't know if it's coming from you or I think everyone is muted. So could you just check at your end if do you have a second source or something?
I don't think so.
Okay, I will mute. I think everyone's muted, but at least at my end it's echoing. Maybe I'm the only one. Sorry about that.
It's happening, yes.
All right. I'm pretty sure I only have the one sound source.
Okay, carry on. Or maybe, I don't know, maybe if you turn your volume down a little bit, maybe there's a feedback loop. Sorry to interrupt.
Yeah, let me turn my volume down then. Okay. So I will talk about the reasoning behind the project, then the elements that are involved in this framework, and then what went well and what still needs to be developed to make the framework work better. And then draw some conclusions how this project went. So,
Jen, you don't have a headset, do you?
no, I joined a couple of weeks ago and I can't afford to replace it because it's the end of the semester and I'm a broke grad student.
Okay, no problem. We're just gonna just carry on and we'll do our best to strain our ears. I'm really sorry.
Sorry, I will speak as loud as I can. So the photo collection that I worked with was from the Spelman College Archives photo collection. And there were all of these pictures in the background are part of it. Some of them are really fantastic. Unfortunately, they're getting fairly little use, even though they are fantastic, because they're hard to find, and the information necessary for some of the preferred uses, like journalism, so names and contact information or permission for use from those depicted aren't known. But by connecting LAM images to larger information networks, we could help more people find these images and also help identify lost information about the content, like who is depicted, and fill in other details, like what they went on to do in life, because that was one of the really interesting things that turned up in research on some of these photos. So here's an example of what the photo archive looks like. It's very list-like. Here is a photo, here's the metadata. Here's another photo, here's the metadata. So it's strictly item level. It does not even separate them into their collections anymore. So even though it is an archive and the physical items are in collections, the digital ones are in photographs. So they're not being managed in terms of what their potential for use is. So they've gone from being an archive collection that represents the history and documents the changes of the institution to now being a digital collection of photographs that they would like to see used more widely. This links data, the semantic web, present really powerful possibilities for item level and even content level connectivity across collections and institutions to provide more of that linkage. But processing non-text items at the item level for collection level repositories is already deeply time intensive. To further describe and connect items with conventional manual methods just seems like an insurmountable hurdle. So that's why my project looked at trying to use computational methods and scripting to streamline that process and take the human manpower out of it as much as possible. So the steps involved taking in an existing metadata spreadsheet, doing text analysis, including natural language processing and entity resolution, and then doing some semantic processing on it. So taking the entities and organizing them into relations, doing some image analysis so we could capture pictures of individual people from within the photos, and then linking those up so that curators, researchers, and the community would be able to contribute and add and build more connections to the data. So this is the standard input file. Fairly common for photo archives. We've got an ID, a title, a date, a text description, and some subject tags. Most of these are LCSH. Some of them might be TGM, the source for graphic materials. So we moved into text analytics on that spreadsheet. So first extracting the item ID, because that's going to be our unique identifier for each row. Then I crammed everything else into a pseudo paragraph so that traditional natural language processing tools might be able to make a little more sense of it. Then I used rule-based parsers to break that paragraph into sentences, tokens, and named entities. Then I output a grammatical tree structure that linguists and computers use to understand the meaning of texts. So this is an example of that tree structure output. You can pretty print it, but this is just the tree structure vertically because that makes the most sense for our use case. So you can see Wine in the Wilderness, February 1989. So we've got like starting to pull out entities here. And sometimes relationships, depending on whether or not the relationship was encoded or not. So the visual processing then came in. So I used EDT, which is based on OpenCV. And it had some issues, which is why this system is not currently available. It had a very annoying bug, which is why there's only one image listed here under images. It's supposed to be able to increment through a number of images, but at the moment that I was doing this project, that was broken. So I had to go one image at a time in its own folder. So eventually, when that is fixed, I can make this available, but at the moment, not so much. But it still works. And you can see the output here. We read in the metadata file. We used it to find this image. It segmented that image to highlight different people. It also looks for other things in the image. This particular system has a very frustrating tie fetish. I presume that's because they trained it on lots of historical portraiture of men in suits. Because it's really good at recognizing historical portraiture poses, not so good at casual poses and dance. And there's way too many ties that it throws up for pictures of women's colleges. It's also got pretty bad context awareness. So cups versus beakers in a lab, not so great. But it did really well with people for the most part, which I did have to check extensively because you can't just assume that any AI system is going to recognize Black people right out of the box, which is unfortunate, but true. So I did test it, and I pulled from the table each class person, checked its probability to see if I would need to adjust or crop the list. I ended up not needing to. I liked all of their existing probability metrics except for on ties. And then it gives the coordinates for the box that it puts around each person. So I pulled that out into its own spreadsheet so that I could then go and draw a box around each person and crop it to that person so that each person can have their own page on the semantic web where their image is there. It's just their image cropped into that photo, and then they're connected to the full photo. So to do that, we have a script here that boxes each of the people. So from the text and the people, we can put together a series of relationships. So for example, item number 01154 has Dublin Core title, Wine in the Wilderness, February 1989. It also has Dublin Core date, February 1989. It friend of a friend depicts friend of a friend person. Said friend of a friend person has been given friend of a friend open ID 214. 214 is, excuse me, is friend of a friend gender female. 214 friend of a friend knows entity Spelman College. And we just keep building out. This shows, here's all of the images in the subset, sorry, all of the numbered people in the subset. Here's the 40 images in the subset. Here's the names associated with the subset that were pulled out, just that identify individual people. We also got some names that couldn't be matched one-to-one to a person, so they're not on this list, but we do have a list of those names. And then up here is the next level up. We've got the photograph collection at Spelman College and people associated with Spelman College. Excuse me. Really, I'm not used to shouting because I have not been at the head of the classroom for a while. So to further evaluate this model, besides evaluating things like the accuracy of the face finding and the accuracy of the NPLK and NLP, I then also did an evaluation of how well and how would the semantic connecting work across multiple, if multiple archives, special collections, libraries, museums started to get involved in a project like this. So to do that, I took 2 photos out of the 40, and I did actual research to put all the names and context to those pictures that I thought the college would have wanted to see. So, for example, here's figure 10 is the existing caption was Spelman graduates in the Women's Army Auxiliary Corps with President Florence Matilda Reed, circa 1942. Afterwards, the research showed Spelman President Florence Matilda Reed with Spelman graduates and members of the Women's Army Auxiliary Corps, circa 1942. Debbie Johnson on the right and Sarah Keys Evans on the left, both remembered as pioneering Black women in military service and important activists for integration of the U.S. Armed Forces. Other side. Over here, our photo was simply Spelman Commencement 1981. Became 3 generations of Spelman women celebrate the graduation of Tanya Trippett on Commencement Day 1981, part of Spelman's Centennial Collegiate Class. Right, Tanya's grandmother, Gertrude Emily Foster, graduated Spelman Class of 1925. Left, her daughter and Tanya's mother, Gertrude Yvonne Ketchum Trippett, graduated Spelman Class of 1952. So this actually shows that there's a lot that can be found, and it's actually a really positive indicator that semantic connections could be really powerful for providing context-level data, because it only took a small number of connections to find this information. The relevance of the facts were easily verified by the connections between the individuals and Spelman. They were very clear and very easy to find. And those connections were found to be both frequent across many websites and contained within well-maintained collections, including full-text digitized newspapers and non-military records, and also in research and reports on Black women's history and the history of the military. And this really shows the potential for the linking component, because while for every one institution that joins and every couple of photos they add, you can really grow that network of information exponentially. So the conclusions, there really was so much to find. The information that wasn't in the metadata turned out to be fascinating and a huge asset to the archive. And in terms of value, going from, this is a photo from the 1981 commencement to actually this is 3 generations of graduates in the same family celebrating the centennial of the college, that's a lot more valuable of a photo. And then all of that information also adds more entry points for people to find the collection, because there's more content that they can get to through search. However, the AI components were largely limited to rule-based parsers for now, so it didn't get to take advantage of things like the Brown corpus or the Penn Tree Bank, things that are built into NLTK to try to parse models automatically. It needed a lot of regex because metadata is so information dense that models trained on actual writing assume that most of it is not going to matter, when actually almost all of what's in metadata matters. Another problem was, while the ontologies have potential, they need to be context aware, and we really need a place to query and choose the tags, so like friend of a friend, Dublin core tags, to get those the links built automatically. So a lot of that had to be done by hand in this iteration, because I didn't know about Hive, for example. I'll definitely be hitting up Jane to ask more about that. But another thing that we learned was, like I said, +1 archive is plus tens of connections. The rapid growth from single photos to one subset of a collection can really just grow exponentially if you have the time to sit down and run this kind of system over a whole collection. Even just without doing the gold standard research, then you can really get a lot of information already up there. And then the point of the semantic web in the linked open data is that you join up with others that can then build that context cooperatively.